Students, we are 75% done with periodic table. We're going to talk about the last group called group 17. Okay, group 17 is called halogens, and the elements include fluorine, chlorine, bromine, iodine. Okay. Now, an important thing to know is that group 17 elements exist as diatomic molecules. What does that mean? It means that they have two atoms, okay? Not diatomic molecules, but diatomic atoms, sorry. Fluorine is F2, chlorine is Cl2, bromine is Br2, iodine is I2. You see the difference between this and group 18, guys? Group 18 was monoatomic. This is diatomic, hence the number 2. Now, I'm going to give you some good news. Group 17 elements have almost the same properties as group 18 elements. So, this is going to be really fast, okay? Let me start with atomic radius. So, atomic radius for group 17 elements. Does it increase or decrease down the group? Just like group 18 and just like group 1, as you go down the group, the atomic radius increases. So I'll just write that down, increases down the group. So the reason for this, let's look at the electronic configuration of fluorine, 2.7. Electronic configuration of chlorine, 2.8.7. So you have more shells filled with electrons as you go down the group, which is the same reason as group 18 and group 1. Okay. Now density, another really easy one. Same like group 18 and group 1. Density increases down the group. And it's the same reason, guys. Change in atomic mass is greater than change in atomic volume. Next, melting and boiling point, the same as group 18. The only different one was group 1. And why did we say that? Because for group 1, the number of shells filled with electrons increases when you go down the group. But wait a second, we don't have van der Waals forces, we have metallic bonds. And when you go down the group, those bonds become weaker and you need less heat to break the bonds. Well, in group 17, it's the same as group 18. Excuse me, guys. When you go down the group, the number of shells filled with electrons increases and you have the force called van der Waals force. So the force increases, okay? The strength between the atoms, the bonds increases. Hence, you need more heat to overcome the force of attraction between the bonds. So melting and boiling point increases down group. Now, one last property we're going to talk about is electronegativity. Now, I love this, guys. Electronegativity is the reactivity for group 17. Now, group 18, guys, never had any reactivity. And why is that? Because it's stable, chemically unreactive, chemically inert. Remember, it's not going to gain or lose electrons or react with anything. So forget about group 18. For group 1, we said the reactivity increases. And for group 1, reactivity is based on losing that one electron. So I'm just going to draw this for you guys. This is what we call the nucleus, okay? The center of the first orbit, the center of the atom, the nucleus. The nucleus always attracts electrons, okay? Nucleus always attracts electrons. So, remember we said for group 1, as you go down the group, you have more and more shells. So, in the last element, the shell that has the one valence electron, it's so far away from the nucleus that the force of attraction between the nucleus and that one electron is so small. There's no force. That's why it's so easy for the one electron to be lost. Now, electronegativity on the other hand works differently, okay? Electronegativity is the ability to gain an electron, to pull an electron towards you. Why do we use electronegativity for group 17? Okay, electronegativity is associated with group 17 because let's take an example of chlorine. Electronic configuration 2.8.7. Should it lose 7 electrons or gain 1 electron? It should gain 1 electron. When you gain an electron, you become more negative and you gain an electron. So electronegative. You're gaining an electron and you're becoming more negative. You see the logic, guys? So electronegativity affects group 17. But how does it affect down the group? Does it increase down the group or does it decrease down the group? Let's not do any guessing, guys. Let's just use our chemistry knowledge. So fluorine's electronic configuration is 2.7. Chlorine's electronic configuration is 2.8.7. Let's just draw it out, guys. Fluorine is here. This is the nucleus. So 2, and then you have another shell. 1, 2, 3, 4, 5, 6, 7. How far is this last shell from the nucleus? Not too far, right? The force of attraction is there. So is it easier to accept an electron? Of course, because remember I told you the nucleus attracts electrons. It wants the electron to come in. So fluorine is very electronegative. Let's look at chlorine. 2.8. 1, 2, 3, 4, 5, 6, 7, 8, 7. 1, 2, 3, 4, 5, 6, 7. Look at the distance between this last shell and the nucleus. How many spaces is it apart? 1 shell, 2 shells, 3 shells. Whereas for fluorine, it was just 1 shell and 2 shells. This electron in the last shell is further from the nucleus than the last electron for fluorine. So the force of attraction between the nucleus and the last shell is less. So there is a smaller tendency or a lesser tendency to gain that 1 electron to become stable. It's easier for fluorine because fluorine's last shell is closer. So conclusion, guys, fluorine is more electronegative than chlorine. Therefore, electronegativity decreases down the group as we go down. You see the logic, guys? Remember, electronegativity decreases down the group. And there you have it, guys. This is opposite to group 1, where in group 1 reactivity increases down the group, and I'm not going to explain why. It's in the group 1 video. So let's move forward, okay, guys? So just give me a second, guys, trying to find out what to show you next. Actually, we're almost done with this. Let's see. All right, so I'm just going to read out what's written in the book, and I'm sure you'll be able to understand this, guys. So the book says, reactivity for group 17 elements decreases as we go down the group. We talked about this. Fluorine is the most electronegative element, and as we go down the group, electronegativity decreases. This is because the number of shells filled with electrons increases as we go down the group. Electronegativity is the ability of an atom to, or an element to accept electrons. Since the space between, or the distance between the nucleus and the valence shell for chlorine is more than the distance between the nucleus and the valence shell for fluorine, it is easier for fluorine to accept an electron than it is for chlorine. Therefore, electronegativity and reactivity decrease as we go down group 17. That's it, guys. You now understand this super well. One more thing, guys. Safety precautions while handling group 17. So, as usual, safety precautions, always use safety goggles and always wear gloves. The other thing we want to talk about is that for group 17 elements, there is something called a fume chamber. Okay, I'll just show you a quick picture. A fume chamber is a chamber in which you handle certain chemicals. So this is how it looks. Okay, you always handle group 17 elements in a fume chamber. Okay, so I'll just write that down. Safety precautions, always use fume chamber. And for the last one, it's pretty self-explanatory. Use safety goggles and use glasses. Okay. One last point I'm going to make note of is the physical state of group 17 elements changes as you go down the group. Okay, guys. Fluorine is a gas. Chlorine is a gas. But guess what? Bromine is a liquid. And iodine is actually a solid. Okay, guys, this may not seem important now, but later on in redox reaction, in Form 5 stuff, we're going to see this and it will all make sense. Okay, guys, so we're done with group 17. Thank you, guys. We just have a trend of periods and transition elements and we are done. So see you soon, guys.